Okay, so how many pairs of shoes do people own? So you were asked to go ahead and fill out this first page. So we have three different displays. We have a dot plot, a stem plot, and then this is a new one that you haven't learned about yet, but this is called a histogram. So looking at these two, and then kind of go along with the bottom one and how they all relate to each other. So how many variables are there? There's one variable. And the variable is the number of pairs of shoes. Let me back that up real quick. And so is this categorical or quantitative? Yeah, quantitative. Because we could find the average and that makes sense. Okay. What is the smallest number of pairs somebody owned? Is 2. So did you get that from the stem plot or the dot plot? The stem, yeah, that's probably the easiest way to read that. Okay, and then what about the highest?
34.
Yeah, 34. Probably from the stem also. So we'll write that stem plot. Okay, number 3, it gives you what the mean is. It's 8.63 and the median is 7. Do y'all remember how to find the median? You can do it from either one of these graphs. Taking it back to like middle school. Anybody? Yeah, we cross them out like this. And you go until you get the middle. So it's right here, number 7. Okay, and then how would we find the mean? Yep, add them all up, divide. So we would probably use a stem plot for that. Okay, so it says, which one do you think is more appropriate measure of center? A median of 8.63 a mean of 8.63 or a median of 7?
I think it'd be the median.
You think the median? Okay. Why would you say the median?
It's like the median's already. It's like a clean number.
It's a good, clean number.
Yeah, it has 8.63.
Yeah.
Yeah, we'd have to round on that. And what else do you notice about the data? I'm going to erase this so we can see it a little better. Do we have some outliers? Do we have some shoe fanatics? Should those shoe fanatics be included in a mean, which describes typical average? You know, it really shouldn't. So these shoe fanatics with 34 pairs of shoes really exaggerate that mean. So we're going to write, which one do you think is more appropriate? So median. Outliers do not affect. I don't know which effect I would use. Do not exaggerate. Exaggerate the median. Like the mean. I don't know if I spelled exaggerate right or, yeah, probably not. Exaggerate, maybe. I don't know. It's okay. That's why I'm a math teacher. Okay, but a mean. So if we had a more symmetrical, like that bell curve, then we could use the mean and the median because they're pretty much on the same line. But if we have something like this where this is skewed, we want to use the median. So remember that for future. So mean is more for symmetric and median is more for any skewed skewed left or right. So those are good measures of center. Because we have two different measures of center. We want to be able to pick the one that would represent the data. Okay, how many students own 0 to 4 pairs of shoes?
8.
8. Where'd you get that from?
The graph on the bottom.
The graph. So here.
Yeah.
Okay, so 0 to 4 pairs equals 8. 8 people. Okay, label which bar on the histogram 5 pairs is on. Where would that be?
The 5 to 10.
Yeah, right here. So 5 is in second column. So this histogram is kind of to like it starts on the left. So if this is 0, 5, then really what's in here is 0 to 4. What's in here is 5 to 9. Here is 10 to 14. And so on. So where the line starts is where that number, which bin, these are called bins. You'll learn about that in today's Ed Puzzle. It's where that number falls. So 5 falls in the category that down there it says 5 to 10, but really what's inside it is 5 to 9 because 10 goes in the next one. Okay, describe the distribution of the number of pairs of shoes. So we have socks, that's our acronym to remember to describe. So our shape. Which one do you think is easier to look at to determine shape? Histogram? I like the histogram. But does it show up in each one? The shape? It shows up. So what kind of shape is this?
Skewed right.
Yeah, because your tail is on the right, so it's skewed right. Okay, outliers. Do we have any outliers, possible outliers?
34.
What?
34.
34. Yeah, let's look at the dot plot. 34 could be an outlier.
22.
22. Do you think this one would be okay? What is that? Like 16, 17? That one looks, I mean, it could be okay, but definitely 22 and 34. So let's just write maybe or possible. Possible outliers. Because right now we don't have a way to determine if they're outliers, but you're going to learn that. Possible outliers are 22 and 34. Okay, and then the center, what did we say we wanted to use for center? Median or mean?
Median.
Median, so we're going to write median equals 7. 7 pairs. And then spread, you really haven't seen this, but we did talk about a specific word that dealt with spread, and that was variability. Does this have a lot of variability or a little bit of variability? We're looking at how spread out they are. I'm going to look here. Do they look pretty spread? Like, it's not all clustered around 5 pairs of shoes.
It's spread out.
It's pretty spread out. So I would say a lot of variability. So a way that we could find spread and name it with one number would be the range. Do you remember that from middle school? Do y'all remember how to find the range? Yep, so it's max minus min. So then our max is going to be 34, and our min is 2. So our variability is 32. That's a pretty big spread on. If we didn't have all these outliers, like the shoe fanatic at 34 pairs of shoes, or the 22, it would have less variability. Okay, let's look at part 1.2. Go ahead and turn the page. So in 1.2, we're talking about dot plots, stem plots, and histograms, all dealing with quantitative data. We've got to know the shape and then be able to describe using SOCs. So dealing with shape, we have unimodal, which means we have one mode, and we have bimodal whenever there's two modes. So an example of a bimodal would be maybe like shoe size, and if you have men and women all surveyed in the same, well, you'd have a woman mode and then a man mode. Usually you could see it in that instance. Okay, and then we have the histogram. We have symmetric in the middle, and then this would be right skewed or skewed right. Let's do skewed right. Let's add an E in there. Skewed right. And then the other one would be skewed left because our tail is on the left. So if it helps you to do like this, to see where the tail is, that might be helpful. And then this one, it looks like a bell curve. Okay, so we need to describe these in words now. So the way we can describe shape, there are symmetric, and then we also have skewed, left or right. And then outliers can be found when there's any gaps in the data. So if you have a lot of data points and then all of a sudden you have one way out here and there's this big gap between most of them and then that one out here. So any data that's far from the other points. Center, we can use mean if it's symmetric. Or median if it is skewed. Okay, and then spread is how spread out the data is. This is variability. How spread out. So you can have a lot of variability or very little variability. How spread out the data is. So we can use the word variability. Okay, we do have to cushion your answer with LY words. The readers on the AP Stats test don't want to see the mean is exactly this number. Instead, they want to use roughly, approximately, typically, slightly, strongly, those kinds of words. So it is roughly symmetric or it's approximately symmetric. The possible outliers are, the outliers may be. Those are the kind of words that you have to add. So approximately, roughly, slightly, typically, and strongly. Oh, I need to add the G in there. There we go. Okay, now I want you to go ahead and do the application problem. Answer those questions. Okay, so use the dot plot to create a stem plot. One important thing you need to make sure you do is the key. And you can go ahead and add the word points on there. So 1, 4 represents 14 points. Okay, describe the distribution. So make sure you use the ly word. So what would we say this distribution would be?
White equals cube split.
So we got some different answers here. Is it hard to tell the shape using the dot plot? It's really hard because you have all level 1s and then only one that's a duplicate. So we could actually look at our stem plot for that. And if we had a few more, like if we had a 40 or a 50, I would say I'd feel better about saying it's skewed. But right now, I think it's roughly symmetric. So you can use any of the ly words. So approximately, roughly, slightly, typically. I think I used approximately symmetric. Okay, are there any potential outliers and why? So if we look at our data, where could we find the outliers easier? On the dot plot or on the stem plot?
Plot and the dot.
Dot plot. So what looks like it could be outliers?
Possibly 14.
Possibly 14. What else?
38.
38. And then these two guys down here. Yeah, because it's outside the data. If you cover up the rest and you just look at from 20 to 28, that looks pretty much grouped together. We've got some gaps here. These would be considered gaps, which we're going to learn how to actually find an outlier soon. We're just not there yet. So possible outliers at 14, 34, 37, and 38. And then y, what would we write as our y?
The gap is what.
Yeah, there are gaps in the data. Okay, and then what measure of center is most appropriate for this distribution? Mean y. Yeah. Mean is most appropriate because the data is roughly symmetric. Okay. Okay, so we are done with this lesson.